You know that poster, right? The one you've seen hanging in pretty much every science classroom ever? That big, colorful grid of boxes and letters? Well, the periodic table is so much more than just a poster. It's honestly one of the most powerful tools ever created. It's like a map to the building blocks of the entire universe. And today, we're going to unpack its incredible story. So, to get started, let me ask you this. What do the salts on your fries, the glowing red of a downtown sign, and one of those helium balloons that's desperately trying to escape a kid's birthday party, what do they all have in common? The answer to that question, and a whole lot more, is hidden inside the beautiful logic of the periodic table. You have to understand, before this neat and tidy chart existed, the world of chemistry was just chaos. I mean, put yourself in the shoes of a scientist back in the 1800s. You know about a bunch of elements, gold, oxygen, carbon, but they're just this jumbled mess of facts. There was no system, no order, and really no way to see the bigger picture. And that's where our hero enters the story, a brilliant Russian chemist and teacher named Dmitry Mendeleev. He was absolutely determined to find the hidden pattern that he just knew had to be connecting all the elements. And his method? Well, it was surprisingly low-tech. Okay, so here's what he did. He started by getting organized. He took all 63 known elements and wrote each one on its own separate card. On each card, he jotted down its most important properties, its atomic mass, its color, how it reacted with other stuff. Then he started sorting them, lining them up by increasing atomic mass, looking for some kind of hidden rhythm. Seriously, you can just picture it. It was like he was playing this massive game of chemical solitaire. He'd lay the cards out, shuffle them around, trying to get elements with similar personalities, that is, similar chemical properties, to all line up in the same vertical columns. It must have been this painstaking process of trial and error. But this is where Mendeleev goes from being just a great organizer to a true visionary. He did something that nobody else had the guts to do. This quote really gets at his genius. Instead of trying to force all the known elements to fit perfectly, Mendeleev trusted his pattern so much that he just left empty spaces in his table. He basically said these weren't mistakes. They were just elements that we hadn't found yet. And those gaps, they were more than just placeholders. They were predictions. By looking at the properties of the elements all around an empty spot, he could actually forecast what the missing element would be like, its mass, its density, even its color. And when those elements were eventually discovered, his predictions turned out to be astonishingly accurate. It was incredible. So Mendeleev gave us the map. Now let's fast forward to the modern table that we all use today and learn how to actually decode its secrets. Every single little box on that table is like a detailed profile for an element. And two of the most important numbers you'll see are the atomic number and the atomic mass. Now, the atomic number is the big one. It's kind of like the element's social security number. It's what makes an element what it is. So the atomic number, it's pretty simple. It's just the number of protons in an atom's nucleus. It's always a nice, clean, whole number, and it defines the element. If you change the number of protons, you've got a completely different element. Atomic mass, on the other hand, is the average weight of an atom, and that's why it's usually a decimal number. All right, so as you read the table from left to right, you're moving across what's called a period. There are 7 of them in total, and as you move along a period, you're just adding one proton at a time, stepping up that atomic number one by one. Now, the vertical columns, this is where Mendeleev's card game really paid off. These are called groups or sometimes families. And just like a human family, all the elements in the same group share similar traits. They behave in very similar ways. This is, without a doubt, the key organizing principle of the entire table. So, with that in mind, let's take a quick tour of some of the most famous neighborhoods on this chemical map. At the highest level, the table's split into 3 main regions. Over on the left, you've got the metals. They're shiny, they're great at conducting heat and electricity. Way over on the right, you have the nonmetals. They're usually dull and pretty bad conductors. And then running diagonally right between them are the metalloids, which have properties of both. Let's start on the far left with Group 1, the alkali metals. Okay, these elements are the rock stars of the periodic table. I mean, they are extremely reactive. They're so soft you can literally cut them with a knife, and their reactivity actually gets even more intense as you go down the column. Right next door in Group 2 are the alkaline earth metals. They're still very reactive, but they've chilled out just a little bit compared to their neighbors. Their real claim to fame is that they burn with these brilliant, bright colors when you heat them up, which is exactly why an element like strontium is used to make fireworks that spectacular, right? Okay, now let's jump all the way over to the other side of the table, to group 17, the halogens. These nonmetals are kind of the polar opposite of the alkali metals, but they are just as reactive. This family is also super unique because it's the only one that has elements that are gases, a liquid, and solids, all at room temperature. And here's a crazy fact for you. The halogen at the bottom of this column, astatine, is so incredibly rare that scientists have never been able to gather enough of it in one place to even see what it looks like. We only know it exists because it's radioactive. Wild, right? And finally, on the far right edge in group 18, we have the noble gases. They are the complete introverts of the table, super stable, unreactive, and they're perfectly happy just being on their own. And hey, remember our opening question? This is where you find your answer. Neon is used in those glowing signs, and of course helium is what makes those balloons float. So from a chaotic jumble of facts to a predictive, elegant map of matter itself, the periodic table is just a monumental human achievement. But it kind of makes you wonder, is this iconic grid we all know and love the final word? Is it the perfect way to arrange the elements, or is it just one perspective with new, maybe even more insightful designs just waiting to be discovered?